Okay, so today we're going to talk about a new concept called energy. We will get to work in power within the next video, but today we're just going to talk about what is energy. Okay, so when you think about energy, I wouldn't even try to picture energy as you would a common object. It's more of an action, or it's a very conceptual term. So energy in and of itself is the ability to cause change. So anything that causes change must have energy. So from making something warm up to making something very cold, to providing a change in, for example, electricity. So you not having electricity to having electricity. From storing something and converting it into chemical energy to be able to use for food or some other source like this lamp here. Radiant energy, something from the sun that helps us grow plants and provide warmth. Thermal energy, whenever you're talking about like a heater or other ways that can provide heat. So all of these are different forms of energy, and they all are just making things change. So you can almost imagine these as if they were just like a different form of money. We've got pennies, nickels, dimes, quarters, dollars, $5. It's just different versions of the same thing. It's all money, but we just use them in different ways. So just like a different amount of money, we have different forms of energy as well. So kinetic energy is the energy of motion. Okay, kinetic means motion. So all moving objects have kinetic energy. So if something is moving, it has kinetic energy, and I mean that in the most basic sense. So this depends on the mass of the object and the speed the object's moving. And we can put this into an equation, and we're going to use this equation to help us a lot. One of the equations that we'll use, and the only one for kinetic energy, is that kinetic energy is equal to half the mass of something. So 1/2 times the mass times the speed squared. Okay, and we do this to help us get this right unit, which is called joules. And so the unit for energy, the SI unit, the unit we'll see for all different types of energy, is always going to be joules, which is noted with J. So here's an example problem. A jogger whose mass is 60 kilograms is moving at a speed of 3 meters per second. What is the jogger's kinetic energy? Well, this is the given part. All right, we're given what we know, the mass, the velocity, and we're trying to find the kinetic energy because that's what the question's asking right here. So we give our equation a try. Plug in half of 60 kilograms times 3 meters per second squared. You need to make this, you can also say it's like this, 1/2 times 60 times 3 squared is 9. Okay, square this first. Okay, then you can half the 60, which is 30. 30 times 9 is 270. Okay, very simple. The next thing is, well, if there's something that we can call energy of motion, we have to talk about energy at rest, and that's called potential energy. So objects that have at rest have potential energy. They have the potential to move, or they have the likelihood that they will move. So potential energy is changed into kinetic energy when motion occurs. So anything that's sitting at any position, any point in time, it technically has potential energy. As soon as it starts moving, so if you throw this ball, its potential energy is going away, and at the same time kinetic energy is gaining. And as it goes up here, the kinetic energy is going away, potential energy is gaining, and then it goes back and forth. Same thing right here. So potential energy, potential energy, potential energy. And it's in that relationship between potential, which is at rest, and kinetic, which is moving, that give us a balance. So the types of potential energy there are, one of them is called elastic potential energy. And that's just energy stored by something that can be stretched or compressed. Okay, so like an example, a rubber band. Another type of potential energy is the chemical bond potential energy, and it's just energy that's stored in chemicals. So we use that for food, we use it for natural gas, things that we can use to burn to help us, gain energy, or a different form of energy. Okay. Another type of potential energy is electrical potential energy, and it's energy stored due to electrical charges, so a buildup. So an example of that might be static electricity. When you've rubbed your feet on the floor, if you've got carpet in your house, and you've stored up a whole bunch of potential electric energy, and when you go touch a doorknob, a metal doorknob, it will transfer those electrons from your feet to the door, and it makes those electrical charges, not potential, into kinetic, and that's how you feel almost like you got a little bit of electrocution. Okay, and also the last one is nuclear potential energy, energy stored in the nuclei of atoms. So the last type, and this is probably the most important type, is called gravitational potential energy. So it's energy stored by objects due to their position above the Earth, hence gravitational. Position above the Earth, gravity. That's what we need to remember. So anything with that has the potential to fall is going to be using gravitational potential energy. So anything up in the air, pretty much. This depends on the mass of the object and the height above the ground. And so for gravity, the gravitational potential energy, we have an equation again. It's the mass of the object times gravity making it fall times the height at which it's at. So remember that gravity on Earth is 9.8 meters per second squared. So an example problem with this would be, what is the gravitational potential energy of a ceiling fan that has a mass of 7 kilograms and is 4 meters above the ground? Well, I write down everything I've got. I write my equation, gravity, there's the mass, and the height. Notice how they don't give you the gravity. You have to know that. Well, all I have to do is plug in 7 kilograms, which is the mass of this, 9.8 meters per second, which is the acceleration it would fall if it fell off from the ceiling, and the mass of it. And combined with that, it has a total gravitational potential energy of 274 joules. You have to have potential energy so that you can actually fall. Okay, it's very theoretical and it's almost a little hard conceptually to understand, but it's almost like saying, well, what makes it so that it can fall besides the force pushing down? There has to be something that actually makes the force be able to happen, and what that makes that actually happen is it has enough energy so it can make this action happen, making it fall to the ground. So one way you can increase gravitational potential energy is if you increase the object's height. Okay, or you can increase the mass, and I'll go back to this problem. If you made this number bigger than 7, or you made this number bigger than 4, you can make this much bigger. Okay, so if you increase the height and you increase the mass, you're going to increase GPE. Okay, so as objects fall, GPE is changed in kinetic energy, and that makes sense. So kinetic energy is largest right before the object hits the ground, thus GPE is the smallest right before it hits the ground. Okay, so this is the maximum kinetic energy, maximum potential. See how it says it right here? KE, maximum PE. Then here again, maximum KE. So the maximum potential is going to be where it's at the highest. And think about it. If GPE has a height in its equation, you want the highest position. That's going to give you the highest GPE. Okay, so if we convert between kinetic and potential, we have something called mechanical energy, which is just the total amount of potential and kinetic energy in a system. So we can use this equation: mechanical energy equals PE plus KE, which is the combination of kinetic and potential, or the combination of rest and moving energy. So what happens to the mechanical energy as PE and KE are converted into each other? So mechanical energy stays the same. As PE and KE are converted, a form of the energy changes, but the total amount stays the same. Pretty much what this means is if we know that a whole scenario, let's say you throw a ball up in the air, and you know that the total energy that it takes to do that is 100. Well, maybe at first you have a whole lot of potential energy and not any kinetic. But as you move, okay, as you throw the ball up in the air, the kinetic energy will gain, which means you're going to have less potential. And then you might have all of that being kinetic and non-potential, if this is PE and this is KE. And you'll see here, though, that no matter at any point, all of these are always going to equal 100. So mechanical energy will always be the same amount in every instance of that scenario. And this just is talking about the law of conservation of energy. It just means that energy cannot be created or destroyed. And we'll get to more of this on the next video. If you have any questions, please let me know. Thank you.